Hello students, so welcome you all again. So it is my pleasure to present this video lecture to you. So this is the third lecture for our chapter vapor power cycle. In first lecture we discussed about basic terminology used in Rankine cycle. In second lecture we discussed about how to solve numerical for dry saturated Rankine cycle. Rankine cycle with dry saturated condition. So today in this lecture we will discuss how to solve numerical of Rankine cycle with wet vapor condition. So for that I am sharing this PPT with you. So I hope that this is visible to you. So Rankine cycle dry saturated. One. This is basically for the this PPT is for. I am sharing another PPT. One. So by mistake I shared another. So now I am sharing this PPT. So this is the PPT for wet vapor. Clear? So first we will try to understand that what is wet vapor cycle or Rankine cycle with wet vapor condition. Here you can see. So last time in last lecture we discussed about this cycle 1A, 2, 3, 4 and 1. Now in this lecture we will discuss about this cycle. Which cycle? 1A, 2 dash, 3 dash, 4 and 1. This cycle we will discuss in this lecture. Clear? So either in this lecture, in this type of situation, in this condition, here we require this x2. Here let us tell it as a x2 and 3 point. Let us tell it as a not 2 days, not 3 days. Here we take it as a 2 point and 3 point. So let us here this is required x2 or x3. Either we require x2 or x3. Then and then we will be able to solve the numerical. Clear? So either dryness fraction at point 2 or dryness fraction at point 3 needed. So here we are assuming that this is given. Which dryness fraction given? Dryness fraction at this point is given. We will assume. So we will solve our numerical according to that. Clear? And at the ending of this lecture, we will also discuss the procedure to find out the enthalpy if this dryness fraction is clear. So let us start with this. So these are the formula. Here you can see how to find out H2, H4, H3, H1. These are the formula. This is the data. This is the table we drawn from the steam table. This is the calculation H2, H4, H1, H3, and finally these are the equation. So this is the overall overview of this PPT. Now again we are starting. So to find out H2, I told you that we have assumed that this is given. So if X2 given, then and then we can find out the H2. Clear? So this is how we can find out H2. Simple, put all the value. Now from where we have to get this? Clear? ये कहाँ से लेना है? तो इसके लिए हम देख सकते हैं कहाँ से लेना है. We need to take it from the boiler pressure. Clear? Now after H2, simple. H4. What is the equation here? H4. HF, simple HF. कहाँ से लेना है वो HF? That we have to take from the condenser pressure. H3. As I told you that S2 and S3 are same. That's why what we have to do first, we have to find out the S2 by use of this equation. Clear? So these two value you have to take from here. X2 already given, X2 given, just these two value you have to take from the boiler pressure. Now S3 is equal to S2, S3 is equal to now you know the value of S3, so put this value and find out this. Clear? Put value of S3 here and find out the X3 dryness fraction at point 3. So from where you have to take all the SF and SFG? From here, from condenser pressure. Then find out X3 and put that value of X3 here. But these two data, HF and HFG, you have to take it from the condenser pressure. So this is how you can find out H3. So 3 enthalpy completed. Which are those? H2 we completed, H4 we completed, H3 we completed. Now only one, H1. So procedure is similar. So whatever procedure we performed in our previous example, so same procedure. Here you can see that VF4, P boiler minus P condenser. Clear? So VF4, from where you have to take condenser pressure. So find out WP from here. Put that WP here and you can find this value. This is already with us, so we can get value of H1. So this is how we can find out all the enthalpy. H2, H4, H3, H1. Clear? So now let us try it with an example. So suppose these are the two pressure given. Which are those two pressure? 35 bar, 0.07 bar. Clear? And I told you that dryness fraction. Here it is written dryness fraction at the end of boiler. Now at the end of boiler means which point? Point number 2. So here it is directly X2 given. X2 is directly given 0.95. Clear? Now then after, here you can see. First of all, draw the table by use of steam table. Take all the data, write all the data. Clear? Then after, for H2, HF plus X2 HFG. So here you can see X2 is given dryness fraction. HF and HFG you have to take from the boiler pressure. So let us cross check it. What is HF and what is HFG? What is HF? 1048, 1752, 1049 and 1752. Okay. Both are similar. Clear? So here we put the data, we found out the H2. Then after H4, let us also cross check here. H4 is equal to HF at P condenser. So let us check HF at P condenser. So this is basically P condenser. This is P condenser. What is HF? 163.4. So here you can see 163.4. Clear? Then after, for H1, I told you that this is the equation. P boiler is 35, that's why 3500. 0.07, that's why 7. And VF, from where we got the VF, here you can see this is the VF. So put this value in this, find out the WP. From WP, put this value WP here. Clear? And from WP, WP is equal to H1 minus H4. WP is equal to H1 minus H4. Now here H4 we already have, so we can find out the H1. I hope you have understood. So this is unit kilojoule per kg. Here all the units are kilojoule per kg. We haven't written it here, but always we have to write unit. Now, this is the lengthy procedure. I told you that to find out the H3, it is lengthy process. So for that, what you have to do? First of all, you have to find out the S2. Clear? For S2 boiler pressure. So put all the value here. Then S2 is equal to S3. So S3 is equal to. Then after this value you have to use. But these two, this and this, you have to take from which pressure? From condenser pressure. From condenser pressure you have to take. So you can get the value of X3. Just put all the value here, X3. From where you have to take this? You have to again take it from the P condenser. So this is how you can find out all the enthalpy. Now rest of the things are similar. Clear? Simple efficiency formula W8. So just put all the value of enthalpy and you can find out the efficiency. Now here I told you that if X3 given, suppose in this diagram, we will try to understand it from this diagram. Suppose, remember this, suppose here in place of X2, X3 given, then what you have to do? So for that, first of all we have to find out the S3. From S3 you have to find out the S2 because S3 is equal to S2. From this you have to find out the X2 and from X2 you have to find out the H2. So basically reverse procedure. So whatever procedure we perform, so here this is the reverse procedure. First of all you have to find out the S3, then you have to find out the S2, from S2 X2, and from X2 you have to find out the H2. I hope that you understood this procedure you understood. Now remember this. Now all the formula you do not have to remember. See here, suppose this is our TS diagram. Suppose this is TS diagram. So suppose if our point is in between, if suppose we are talking about boiler pressure. So here what will be the enthalpy at this point? At this point we have enthalpy HF. At this point we have enthalpy Hg. At this point we have enthalpy Hg. This point HF. This point Hg. Now what is the enthalpy at in between? In between obviously HF plus X into HFG. So this is the formula in between. Clear? So remember this. Now if so superheat condition, so that we will discuss in our next lecture. But remember, if point is here, formula will be HF. If point here, formula will be Hg. And if our point is in between, our formula will become HF plus X into HFG. So this value depends on X, dryness fraction. So we all know here we have dryness fraction lower around 0.1, 0.2. At this point in between we have dryness fraction 0.5 and here it will increase, and at Hg our dryness fraction is 1. At HF our dryness fraction is 0. Clear? I hope you have understood this properly. So in detail we will discuss again in our third example. Clear? So I hope that you are understanding or you are getting or you are understanding from this lecture, and these lectures are becoming useful to you. So thank you all for listening. In case of any doubt, you can contact me. So thank you.